All right, so level 2 is all about partitioning a line. We're not going to cut the line in half. We're going to now start to cut the line into a specific ratio. But we're still dealing with horizontal and vertical lines for this level 2. So it says find point B on AC such that the ratio of AB to BC is 3:1. So A is here, and C is here, and we want the ratio of AB to BC to be 3:1. So let me just draw that line. I'm going to off to the side of the graph here, and I'm going to show you what that means. I don't want to draw it on the graph because I don't want you to get confused at where B is at. But it means that B is going to be somewhere on this line segment so that the ratio of AB, which is this segment, to BC, which is this segment, is 3:1. So what that means is that point B lies 3/4 of the way from point A. Okay, so that's important that you recognize that point B lies 3/4 of the way. And so now point B is going to be somewhere along this line segment. So since it's a vertical line segment, we know that point B is definitely going to have an x value of 3. It's going to be the same x value as A and C have. But now what we're going to do is, just like when we did the midpoint example, we're going to find the distance of this line. However, we're going to do it slightly different than what we did with the midpoint. We are going to find the distance from point A to C because I wrote my ratio of 3/4 from point A. So from A to C, I'm going down 1, 2, 3, 4, 5, 6. So we're going to write that as a -6. -6 is not the length of this line. It's just what's happening from point A to point C is we're going down 6. So we represent down 6 as -6. But again, don't get that confused with the distance. So down 6. And so we're going to take the 3/4 and we're going to multiply it by -6 to represent that down 6. Basically what we're doing is we're doing the rise, the slope, and the slope is from point A to point C is down 6. So if I do a 3/4 times a -6, that puts me at a -4.5, which would put B all the way down here somewhere. And so that's not where B ends up. What we need to do with that then is we need to add it to the y value of point A, because we want it to be 3/4 of this slope here, of this distance from point A. So I need to add the y value of point A onto that. So point B would then lie at 3.5, or 1/2 if you want to write it like that. So right here, that splits our segment up into a ratio of 3:1, and B is 3/4 of the way from point A. So now, number 2, we need to be careful. This is slightly different. We want to find point B on AC such that the ratio of AB to AC is 2:1. So if I graph point A, which is at 2, 4, and I graph point C at 4, 4, this is my line segment, and I'm just going to draw it off. I'm going to draw it a little larger off on the side of the graph just so we can talk about this. So point B is going to be somewhere along this line segment. We don't know where yet. I'm going to put it here for right now. And we want the ratio of AB, that's this, to AC, which is this whole line segment, to be 2. Sorry, that should say 2 to 3. And it is changed in your notes. So what this means is that point B, this one's a little different, lies 2/3, we already are given the whole segment, 2/3 of the way from point A. All right, so for letter B, since this is a horizontal line, we know that the y value is going to just be 4. It's going to be the same as what A and C are. And now what we're going to do is, sorry, I should have left a little bit more room to find the x value of point B. So what we're going to do is we calculate the distance from A to C. So from A to C, I'm going over 1, 2 to the right, which means that's a positive 2. So I'm going to take my ratio of 2/3. I'm going to multiply it by that distance, that slope of 2, and then I'm going to add it to the x value of point A. So point B winds up being at, and this isn't going to work out very nicely for us, a 4/3 plus a 2 is a 3 1/3. And then my y value is 4. You don't have to graph it on the graph. If you want to, that's fine. It would be about there. Great. So number 3 and 4 we're doing without a graph, but it's the same process. So we're finding point B on AC such that the ratio of AB to BC is 1 to 4. So let's just roughly sketch what that would look like. And actually, sorry, I'm going to do it a little bit more accurate. Since they have the same y value, that would mean that this is a horizontal line that we're talking about. Point B is going to be somewhere on that line. We don't know where yet. But we know the ratio of AB to BC, so AB to BC is 1 to 4. So this means that point B is 1/5 of the way from point A. Since this is a horizontal line, point B is going to have the same exact y value as point A and C, that's 10. And so then our process is we are going to take the length, the distance from A to C. Now be careful with this. 4 to a -8 means that I'm going back, I'm going to the left, so backwards, so in the negative direction. By 12 units. So I take my 1/5 ratio, I multiply it by that -12, and then I'm going to add it to the x value of point A, which is 4. So point B is going to be 1.6 is your x value, and 10 is your y value. If you wanted to write it as a fraction, that would be okay. it would be a 1 3/5. Either one of those would be acceptable. Okay, and number 4, this time both my x values are the same, so this is going to look like a vertical line. So A to C. And sorry, this one should have been drawn a little bit differently because C goes on this side and A goes on this side according to the graph. All right, but your rough sketch doesn't have to be exact. So for this one, we're going to plot point B somewhere along this line segment such that the ratio of AB to AC, which is the whole line segment, is 1 to 4. So what that means is that point B is 1/4 of the way from point A. So for point B, it's going to have the same x value as A and C because it's on a vertical line segment. And going from point A to point C, that means we're going up from A to C, so we're going in the positive direction. So going from a -7 to a 5 would be going up 12 units, a positive 12 units on the graph. And so we'll take our ratio of 1/4 and we'll multiply it by the positive 12 units. And then we're going to add that to our y value of point A, since point B is 1/4 of the way from point A. So B would be at 18, and then a 12 times a 1/4 is a 3, plus a -7 is a -4. And that brings us to the end of this lesson.